Design and Technology, Engineering Principles and Systems, Balloon Car, Introduction. So we're looking at creating a balloon car by 3D printing, and we're going to go through this and consider a range of parameters in order to change the design of our balloon car to get the optimum, or what we believe will be the optimum performance. And we're going to think through this, and here's an example of thinking through it. So I'm going to look at a parameter and I'm going to look at the air outlet height, and what I'm talking about is where the air is coming out to blow the car along. So if the air goes out, the equal but opposite reactionary force will push the car along through that vector, through the middle of the air vent out. And the air vent out is not as big as that whole tube, it's a bit smaller than inside that whole tube. But we're going to work it way through and we'll get a force pushing through at that vector. And if we were to change it, say for example move it up higher, the force would come through at that point there and be pushing on the car at that point there. And it's fairly accurate to say it's a fairly pinpointed force, but it's going to act on the car in a line down to the first axle that it comes across. And it's going to create around that axle a moment, otherwise known as a spinny force. Not really known as a spinny force, but it's going to create torque around that axle. Now, if we extend the next one out to the next axle point, there's another lever going out, and that's also going to create or spin around that point, but it's not going to be able to. So what it's going to do is create a downward force on that that point of the wheel, and that will be greater the higher up the air is flowing out. So for the highest arrow, it's going to be higher or greater downward force on the front wheel than for the lower arrow. And then conversely, we'll get a spin torque going around there, which will create a small lift force on the back wheel. And I'm thinking about this parameter, the height of there, and I'm thinking about how it's going to impact on the drive of my particular vehicle. And I'm going to ask the question, is this even significant enough for us to consider? So all these things could happen, but are they significant for us to consider? So we need to go through all our parameters and think about what are the most significant things we need to work on. Is this one that we need to work on? Should we change the height, or should we just put it at the middle? Should we put it lower? Should we put it higher? That's up to you to figure out, and it's up to you to figure out whether or not it's even worth considering that. So we're going to go through our project and think about a whole range of parameters, not just the outlet height, but we're going to go through. As part of this project also, we have some constraints. Some of our constraints are administrative constraints, and what I mean by that is they're rules that I have set. I could change them, but I'm not going to. These are the rules that I'm setting. The rules that I'm setting are to do with sizes, and the total possible length of your balloon car is limited to 120 millimeters. The total possible height of your balloon car is limited to 40 millimeters. And the total possible width of your balloon car is limited to 40 millimeters. So that will basically be how big it is. My reason for this is it's how much time it takes to print. And if the one that I would change that would change the most in print time would be the side view, the top-down view, the 40 millimeter wide bit. If I change that, for example, to 35, I would save a good couple of hours on print time, but I'm not going to do that. 40 by 40 by 120 are the maximum sizes. So there is a workaround for this, and that is that if you think about the side view of this on a grid, and not worried about the 40 millimeter thickness, the side view on the grid, we can move the squares around. So for example, the top one, that's just the standard size grid. If we look at the bottom one, I've blacked out a whole section, and I've moved that whole section up to another point. So for example, I could put my balloon spigot, which is the thing that the balloon attaches to, up on top of that, and that could get the extra height that I needed. and therefore I can actually use that space. So I can take space from my design and use it, but I can't draw my car or balloon car into the black space. Hopefully you understand that, but you can borrow squares and move them around. That's all I'm saying. The reason for this is that the time on printer differential for the top one and the bottom one is minimal. It will take slightly longer to print the bottom one, and it will actually mean that I can possibly fit less on the printer because of the odd shapes. It's easier to print lots of rectangles than it is to print odd shapes, but the time on the printer is not going to change that much by moving one lot of area to another, because it does come down to area. The other limitation we have is a stock limitation. We get tires. We can only get tires of a certain size. The tires are literally going to be rubber O-rings. You'll get some supplied, but if you need to get your own because you want bigger wheels and you want to test something, they're not very expensive, but they're just like tricky to get. You need to actually be able to get your wheels to be the size that you need for your particular design. If you look at the design on the screen, you can see that the wheels are a bit small. They're 20mm wheels with a 3mm round on the rubber.